So here we've got a cubic function that we're trying to find all of the zeros for. So we start with the Rational Zero Theorem, which states that, let's call that our constant term, and 1 here is our leading coefficient. We take all of the factors of 18, divide them by all the factors of 1. Since I'm dividing by 1, it's really just all the factors of 18. So I'm going to list them up here, plus or minus 1, 2, 9, and 18. So really we have 8 things that we could possibly try. Where do you start? Start with the small ones and then work your way up. It's rarely going to be these larger ones here. So start with the small one. We'll start with 1, see if it works, see if we get a remainder of 0. If we don't, try negative 1. 1, negative 4, negative 15, 18. So bring down the 1, multiply, negative 3 when I add, multiply, negative 3, negative 18, multiply, and you can see that this one's going to work. Okay, so from here you could go back to the original list. Since this constant term, negative 18, is still the same, you really have the same set of possible zeros. So you could try another one of those, divide whatever your answer is, see if you get 0, or since the thing is quadratic, why don't you just try factoring the quadratic? Alright, don't mind if I do. 18 equals 0. Open up my parentheses. I know that's got to be an x and an x. And we have to have a product of negative 18, and they have to add up to negative 3. So that's going to be minus 6 and plus 3. So when I solve each of these, I get x equals 6, negative 3, and then of course my original 1. Here are all the zeros of this cubic polynomial function. If you were to graph these, if you were to graph this function, 6, negative 3, and 1, of course, is where it would touch the x-axis, x-intercepts. Let's try another one. So just like before, my constant term is 14. My leading coefficient is 1, so whenever I go to find all of the possible rational zeros, just really the factors of 14, plus or minus 1, 2, 7, and 14. So, just like before, start with a 1. 1, negative 8, 5, 14. Bring down the 1, negative 7, negative 7, negative 2, multiply, negative 2, 12. That doesn't work. So let's try negative 1. 1, negative 8, 5, and 14. Bring down the 1, negative 1, add it, negative 9, multiply, positive 9, gives us 14, and magically this one does work. So again, I could pull another one from this list, or just try to factor this, x squared minus 9x plus 14. Open up my parentheses here. I get x, and my only factors for 14 are 2 and 7. They both have to be negative. So x is equal to 2, 7, and negative 1. Alright, one last one. So we've got 35, negative 35, divided by 1. So plus or minus 1, 3, nope, that's stupid, 5, 7, and 35. So let's just try 5. 1, negative 5, 7, negative 35. Bring down the 1, multiply, 5, 0, 0, 7, 7 times 5 is 35. Add it, I get 0, so that works. So what we have here is x squared plus 7 equals 0. So I can just solve this by subtracting the 7 over and taking the square root is plus or minus the square root of, well, that should be negative, negative 7, which is plus or minus I square root 7.